Okay, I'm going to get started. Today, we have a very short lecture on a very useful topic. It's called the Model Context Protocol. This is what just got a student a job within weeks of learning about MCP and building his MCP app. He had an internship building MCP servers for Intel. So if there's any week that you want to pay attention and actually do a really good job on your homework, this is the week. In fact, if you get interviewed over the next 6 months or a year, lead with MCP because it is the way to get hired right now. Like in this time, in this year, MCP is it. So that's my advice to you. What is MCP? It's called the Model Context Protocol. And the reason why I start you off with agents last week and then transition is for you to see the drawbacks of what you just did this week. So what you just did this week is that you built an LLM application and you built a bunch of tools and it went off and it accessed some services over the network. So initially, that's the way we did LLM applications. LangChain was deployed with all of these built-in tools, and it was like, wow, I just have to look at what LangChain has supported, and I can go ahead and utilize whatever they have. But because they're implemented within the application, you have everybody with their own slightly different way of using these implementations of like tools such as like GitHub tools and Google Drive tools. And moreover, if one of these vendors decides to change the way their service works, every single LLM application has to be updated with that vendor's new way of doing things. And that's not very good. It's not very helpful. We call this, this is what fragmented tool development refers to. So you don't want that. And as it turns out, the Model Context Protocol, this was developed by Anthropic just over a year ago. And they were using this, if you've ever used Claude Desktop, this is what was being used to allow the Claude sort of like model to go out and get functionality from the web, get context from data backends. And they were using this MCP, they had developed this protocol and they were using it internally. And then they decided to open source it in November 2024. And then immediately this thing took off because it's basically an interoperability layer for connecting LLM agents to the tools that they want to use. So that's what it is. It's basically using JSON RPC. So if you've taken the cloud class, you kind of know what that is. It's kind of like a web API call, but you're actually invoking it with a JSON blob and getting the results back and forth through JSON. And it's more than just accessing data. REST APIs are typically, I'm just going to access this API endpoint to get data. This is a true RPC. You're actually invoking function calls on the other end, and that's what they utilize here. And so this protocol enables the LLM to invoke tools that are provided remotely by someone else potentially. So the analogy that I like to use is that when the browser is discovering and accessing web services, the browser does it through the web protocol. When the agent wants to discover and utilize tools, like the tools that you just built, they're using MCP in this day and age. So that's the idea. So here's an example, the Google Drive MCP server. Google releases the blessed version of the Google Drive MCP server, and then everybody who needs integration with Google Drive can build against this MCP server. They could deploy an instance of their own on Cloud Run, for example, and enable it with their OAuth credentials. And then they have a natural language interface to invoke tool calls for all the tools that the Google Drive MCP server exports. Now, in your labs this week, you'll be doing your own mini MCP Google Drive server, because basically the code that you see in there is similar to the code that's in here. Well, it's way more stripped down, because I actually want you to see how you would build your own MCP server. And then when the project will be that you'll utilize a reference server that someone else provides, and you'll be building one of your own. So you see the whole chain. Okay. So there are tons of MCP reference servers that are out there. You go to this URL, and you see all the different front-end AI agent frameworks have MCP connectors to allow you to access all of the reference servers that are there. You can see like GitHub, Slack, Snowflake, Dropbox, Google Drive, they all have MCP servers. I would caution you though, some of the servers on this list are just community contributed, and you can't really tell the source of like who's contributing these things. The vetting process is unclear. So this is one of the things I would like you to do in your homework, is that before you decide to choose an MCP server to integrate, you better vet that thing. You better check to make sure there's not like malicious code in there. You could probably copy and paste some of that code into a chatbot and say, is there anything malicious in this MCP server? And then if it doesn't find anything, you'd be like, okay, that's the one I'm going to use for my project. You'll be running this stuff basically on your cloud project. So hopefully there's no personal sort of data there for rogue MCP servers to destroy. But definitely run this on infrastructure that you don't care about, which is basically infrastructure on your Google Cloud account. Because otherwise, you really do need to make sure you have done an analysis of the MCP server that you're actually bringing up. And code analysis and sort of like analyzing code for vulnerabilities and exploits, that'll come in like 3 or 4 weeks. So I would recommend doing those tools and applying it on anything that you run before you go and you run it. Okay, so here's another picture. Basically, MCP is standardizing AI development. So you have any MCP compatible application, and then you can just call out. You can just say, configure this agent with these servers and the tools on all of these servers. So this is a data store. Maybe this is your database MCP server. This is your customer relationship management server. And this is your GitHub version control server. And then you allow this application to just leverage these things rather than implement them within its own application, which is what you did this week, just because I wanted to show you the pain of that and then show you the way other people do it now, which is via MCP implementations. Okay, so here's an example. You have an agent, and this agent integrates MCP servers from HubSpot, GitHub, and Slack, so that when someone asks for the closed deals, it goes to HubSpot, which is the customer relationship management software. GitHub PRs go to the GitHub MCP server, configured with whatever repository your company might have, or you personally might have. So if you deploy your own GitHub MCP server, you would configure it with your own GitHub tokens, and then you could just query your repositories using this. And the same thing with Slack. If you're an administrator on your own Slack workspace, you can bring up an MCP server that integrates with Slack and then provide your Slack credentials for the workspace to allow the MCP server to get access to your Slack. And then you can have a natural language interface to your Slack workspace. No one's done that yet for the PDX-CS Slack, but you could, and then I might use it. I'm like, summarize all the messages in this class and let me know if anything's urgent. And be like, and then send me a text message if something is urgent. If a student's hair is on fire, I better get that notification. You could build that with an MCP server and an agent in this case. Okay, so MCP is kind of analogous to REST APIs. So if you took the cloud class, REST APIs were a standardized way, and actually Swagger and OpenAPI, these are standardized ways of publishing the capabilities of your API and allowing a client a machine-readable specification so that the client knows exactly how to leverage your REST API. MCP is exactly the same thing for tools. What are the capabilities of my tools? What are the format of messages that you need to send to me to invoke my tools? So similar thing as Swagger, but like done for tool calls rather than API calls. And in fact, you can now go from the LLM application. So this was the OpenAPI agent toolkit. Like before we had MCP, we were doing like, oh, let's have the LLM application parse the REST API, the OpenAPI spec, and then craft those calls to access this API. So you can get rid of this, and you can instead say, I'm going to export the tool that is the intermediary, and then the MCP server itself is the one that programmatically accesses the REST API. So there's like two ways of doing things. So there was this XKCD example that you ran. So rather than actually having the agent parse the open API spec for XKCD, you would just write the custom tool that had this logic and then allow the LLM application to just invoke those tools, those custom tools instead. Okay, and you'll find you'll get much better behavior for your agent if you do this, because you can actually constrain what the agent does based on the tool calls that you've implemented. So later on, when we do command generation and we give the agent just arbitrary access to a Linux command shell, we'll see that that's a terrible way of doing things, versus if you have a purpose-built command shell agent and you only give it access to particular Linux commands, then it's much more constrained and it gets you better results. Okay. So I'm going to go into the low-level details of this. This might be the last time you look at this, though. So there are two parts. There's the MCP client, which is the AI application that has the agent running on it. And this is an application that requires either data or tool. So MCP is meant for exposing data, or resources is what they call it. And then tool calls, which is function sort of invocations. It's also got this thing for skills, but we're not covering it in this class. But you can look into skills if you want to as part of your homework. And then you have the server that is able to provide either the resources or the tool call on the back end for the client to execute. Now, there are two ways to run MCP. If you're running everything locally, you can run this over standard in and standard out. So the client and the server are resident on the same machine. And then when the client needs to invoke the server, it just calls Python. It invokes Python and brings up the server. And then the communication back and forth is with standard in and standard out. It's like local IPC. But the real power of MCP is when you invoke it over the network. And it can, as a carrier protocol, it can use HTTP. It can use streamable HTTP, and that's actually the standard. So it was started out with regular HTTP, and then it was HTTP SSE, and now the standard way of doing MCP over the network is streamable HTTP. Now, I got unlucky. They changed the package in like 2 weeks ago over to default to streamable HTTP, and it broke a bunch of my MCP labs. So then now a lot of your labs are just using the standard in, standard out, because I'm like, I don't have the bandwidth to actually shift all my stuff over to streamable. So now we're mostly doing this. There's like one example where you're using an older version to do it over HTTPS, but then everything else is going to be standard in, standard out. Okay, so this is the figure. You have the client. It's speaking MCP to discover tools and then to invoke them. Those are the two things that are going to happen over MCP. And then the server has got all of the tools for the specific APIs that the agent needs access to. Okay, so this is the protocol. Right at the beginning, there's this discovery phase. So it's very similar to an open API retrieval of a specification. I was like, hey, there's an API. What do you implement? Let me download your spec. That's what this is. List all the tools that you support. You get everything that this server supports, all the tools, and the description of all the tools, how you actually invoke each one of these tools. And this is super important because that is what trains the LLM, that teaches the LLM how to call the tool. And so it's really important. The developer is the one creating the description and saying, giving the instructions on how to invoke the tool. You as a developer, when you're developing your own MCP servers, you have to be very precise because you're teaching an LLM how to use your MCP server. And if you get that, if you're fuzzy with your specification, this is why we did all that prompt material in the first week. If you are fuzzy with how you specify it, your agent's going to break. It's not going to know how to use the MCP server that you just built. So really fine-tune the way you describe all of your tools when you build your MCP server. Okay, and then when the client actually wants to invoke a tool, so it's learned exactly what the tools are and how to call into them, it basically will format a call to a specific tool, and this is done over JSON. It's JSON RPC to invoke the tool call. And this is why I showed you earlier, this tool calling benchmark. This is what you are hoping the LLM is good at. It's good at identifying the tool to use, and it's good at formatting the correct JSON to invoke the tool correctly. And those things can break. That's not going to work 100% of the time. So, you have to get used to, in this class, you could run something and it might break the first time. And then the second time, it's like, it works. And then you're like, what's going on? Because we're not used to non-deterministic behavior. You're going to get plenty of non-deterministic behavior because it's a combination of the application, the data that you're providing the agent, the tool call, and then the model that you're using. So there are some examples that used to work that I don't know if they'll, in fact, actually someone who's working ahead is already like, I don't think this thing works. And I'm like, yeah, it depends on the model and it depends on the implementation that has changed. Okay, so I mentioned this. This is the URL to look at all the reference servers. You're gonna do so in the lab, you do a fetch, you do a Git, not a GitHub one, you just do a Git server that your Git repository is local. So GitHub is when you're trying to access the repository remotely, but there's a Git MCP server that's built in the lab. You're gonna do, there's curl, and then there's a SQLite one that you'll be using in the labs. And then so there's a list of them. Here's another one that is interesting, Playwright. So if you want to automate your web access with an agent, this one is also something that I've seen people have interest in. So I brought that to your attention. Okay, so now I'm going to give you just some code examples. And there's not a ton of code here to show. It's very simple. This is what the server looks like. I have an MCP server for querying this database. And this database comes from the MetaCTF users. So this is an example database, and you want to have a natural language way of querying this database that an agent, an MCP client, can invoke the MCP server with a query to get that sort of data out of that database. And so here is your tool. This server, it could do many tools, but this is the one tool that it has. And it says, just give me a SQL query, and I'm going to execute it against this database, and then return the result. And so I start you with this one because this is horribly vulnerable. It's like, you should never do this. So maybe I shouldn't show it to you, but what I'm going to do is show it to you first and say, never do this. Right? This is incredibly insecure. And in your lab, you'll go and you'll delete the database and you'll do SQL injection and do all of these things. So not all of you have taken the Web and Cloud Security class or the database class. This is vulnerable. Well, this is vulnerable to straight up drop the database, but it's also vulnerable to SQL injection because the way you're handling this SQL query is to just take a SQL string and just pass it to the backend. So this is what you'll be experimenting with your very first MCP server. And you'll see there's all sorts of security problems with MCP servers. And so the second thing you could talk about in your interview is that, yeah, I've looked at securing MCP servers because they're horribly insecure. Like the people developing these MCP servers, they might not have security in mind. And then you can talk about how, yeah, you have to. So then the next version of this, so there's a more secure version of this, where you actually do very specific tool calls that only implement specific queries on the back end. It's not going to allow you to do arbitrary queries on the back end. Who would allow you to do that? This is called excessive agency, which we're going to talk about next class. We'll do all the security problems next class. But one of the things that this is basically excessive agency because you have like full-on access to this database backend. And what you need to do is a custom tool with much more restricted functionality. And those are the tools that you export to the agent. And then hopefully you've also gotten rid of the SQL injection, which is another issue here. Okay, here is an example of a client agent. You just, you tell it that you want to have access to this MCP server using standard IO. So this will pop up the MCP server on your same machine and communicate over standard IO. And then you just prompt your agent with the, similar to what you're doing with your agents this week. And then you're basically loading all the MCP tools, creating an agent against the tools that were created. and then invoking what are the users in the database, and you can see the query that goes across MCP is select star from users, and you'll get it back. So this is just showing you the nuts and bolts of what's going on with MCP, and then slowly scaffolding you up to a more secure implementation. There is an implementation that uses Cloud Run, where you take the MCP server, this thing, and you can deploy it on Cloud Run, and then try and get the client to access the remote MCP server. So that's the one that is sketchy. That may or may not work with the changes to MCP. Okay, so that's it. I'm going to talk about the lab. So Google Drive, Git, Fetch, and curl these are custom MCP servers for you to look at. They're very small pieces of code that you can deploy, interact with a client agent just to see how it works. And then the idea is from that, you're going to implement something of your own that's not one of these four. So you can come up with your own ideas for MCP servers and build it and run it. And then I want you to actually go and look for one of these, find a reference implementation, and go and add that to your sort of MCP server selection. And then I want you to have an agent that can basically do a multi-step prompt that utilizes tools from not only your own MCP server, but also the one that you've integrated. So this is someone else's MCP server that you can integrate, and then this would be something of your own. And then the idea is to build an agent that kind of uses both of them to solve a problem. And so hopefully they're related. You pick two things that are related, and then you go from there. And then you have experience doing both parts of the MCP development. Okay, so with that, the rest of the class, you can do all the labs and start on your homework. Are there any questions about MCP before? It's a free-for-all. I mean, get as much work done as you can, but I'll just stick around for the next 2.5 hours and answer questions.